So good afternoon class. Today we are going to discuss about data link layer. So this is the first part of data link layer. So I am going to discuss about what are the things that are actually performed by data link layer. Now let's suppose I have some so first of all let's discuss briefly what does this architecture is. So first of all, we know that we have application layer, files on the application layer. Then we have transport layer. So application layer has files, okay. Transport layer has segments, okay. Then data passes to next layer, which is network layer. So in network layer, data is in the form of packets, okay. Then we have data link layer, okay. Data link layer, so data is in the form of frames. And then we have physical layer, okay. Physical layer is over here, and in physical layer we have bits. Now these bits are transferred over a channel, and then this whole part is the sender part, this whole part is the sender, this whole and then the exact same thing is done over the receiver. So here data is received by physical layer at the receiver. So here you have this physical layer, again physical data, you pass the data from physical layer of sender to physical layer of receiver. Then it goes to data link layer, then it goes to network layer, it goes to then transport layer, and then the application layer. So what we are going to discuss today is data link layer. Now you can see data link layer and physical layer, these two layers are have so many things in common. So most of the things in data link layer are designed as per the physical medium. So if physical medium is suppose your LAN wire, so data is transmitted via LAN wire, so it's transmitted in the form of signals or bits, right? Now for the data link layer to be transmitted via LAN wire, it should be supported. Physical layer, it should support physical layer can only send bits, that is signals, high signal, low signal. So this LAN wire attached to devices, LAN wire is attached to two devices, sender device and the receiver device. Now those devices should support the data. We support that Ethernet maybe, or ATM or frame relay, whatever underlying network. So it should support underlying network. So data link layer basically provides the support to physical layer, okay. Now let's start with the basics. So what does it do is, so basically the work of data link layer is to send data from one node to another node, okay. So data between node is sent by via communication channel is sent by using a data link layer, and the data that is as I have already told you, it's in the form of frames. So data link layer converts the data into frames, and then physical layer converts the frames into bits, okay. So here you have data frames, and this link can be wired link between two devices. This can be wired, wireless, or LAN, okay. So this is basic architecture. Now for example, suppose you plan a trip from Princeton to Lausanne, and so what do you want to do is, first of all you will take a car or cab, then you will take a plane, and then you will take a train, right? So tourist is basically the datagram that data is transmitting, and transport segment is like communication link between the two ends. And transportation mode is the link layer protocol, via which protocol that you are going, and travel agent is the routing algorithm. Now so travel agent is nothing, it's just how data is moving hop to hop, okay. So now first of all, these are the services that are provided by the link layer. So first service is the framing. I have already told you that data is in the form of packets on network layer, and these packets are then sent to data link layer, and then data link layer converts it into frames. So framing is the important part which encapsulates the data coming from network layer into a frame by adding a header and a trailer. Okay, and then it passes the frame to the next layer, which is the physical layer. Okay, so reliable delivery between adjacent node. Adjacent node word is very important because it provides error checksum. Okay, those kinds of things, error checking, checksum, these kinds of things are provided by link layer, data link layer. Third is flow control, error control. Flow control is suppose first sequence of bits should be transferred first, second sequence of should be transferred after the first sequence, so that is flow control. Error control is detection of error in the data that is received by the receiver. It should not be containing error. So first of all it is detected. Now if there is error, it is also corrected. So error correction is also one of the tasks of link layer. Now half duplex and full duplex. So which half duplex is only at one time only sender is sending either, or either receiver is sending to sender. Okay, so if data is between A to B, transferring between A to B, so at time t1 either A will send to B or B will send to A. That is half duplex. In full duplex, both can send data at the same time to the channel, and all the data is at the channel from left to right or right to left simultaneously. Okay, then next is error. So first let's discuss first task, which is error detection and correction. Now we will just briefly introduce about this topic in this lecture, and in next lecture we are going to get into depth of it. Now there are two types of error. First is single bit error and second is burst error. So what is a single bit error? Single bit error is nothing, it's just change in one bit. Suppose you are sending 110 from sender to receiver, and only one bit changes and you receive 100. So second bit changes, so that is single bit error. It is easy to detect and correct. While burst error are suppose few bits at a time, few sequence of bits are changed, so that is a burst error. More than one bit are changed, so that is burst error. Okay, now there are many methods for detecting errors. Now there can be many methods. All of these utilize this. Actually, what is this? You have data, sender is having data. What it does is it adds some error detection and correction bits. It adds some bits over here and send its own data plus EDC, data plus EDC to the channel. Now channel can either change it, it can induce error in the data that you have sent, or it can pass it as it is. Now whatever it has received is D dash. Now EDC, whatever it was having, it will also be having same EDC dash, same. It those bits it knows. So sender and receiver both knows EDC. Okay. Now again it checks. So it applies a mechanism to know whether the received bit are same as contains error or not. Now we will see how does this work. Suppose this is the data that we want to send, and we say that the data is having, let's say, even parity. So what you will do, you will create even number of ones in the data. So let's count the ones in the data: 1 2 3 4 5 6 7 8 9. So suppose you want to create odd parity. Okay, now sender and receiver both knows that data is at odd parity. Now there are 9 ones, so what you will do is it will add a parity bit. So to make 9 ones, to make odd number of ones. Now if we add 0, odd number of ones are remaining. If we add 1, we will have 10 ones, so which is not odd number of ones. What do we want is sender and receiver both know that our data is odd parity. Odd parity means odd number of ones. Now so it will add 0 over here and it will send the whole data. Now if only single bit error is there, so either of the bit will flip. So suppose this 1 flips to 0. Now what it will receiver will receive? It will receive 8 ones, which is not odd parity. So receiver will say, okay, the data that you have sent is containing error. So this is the idea behind the error detection. Now similarly in two-dimensional parity, detecting error as well as correcting error is possible. Why? Because error correction is also possible, because suppose whatever you have sent, so if this blip, if 1 is flipped to 0 over here, so there are changes in row as well as column. So this will change, and this value will change. So two values will change, so one in row, one in column. Now these values will change. This means there would be single bit error, and you can identify in which row and in which column. So detecting and correcting error is also possible in this case, because you can identify which location bit is flipped, while in single bit parity you cannot identify which bit is flipped. Okay, so that is the exact idea behind error checking and correction. Now we will continue with this in the next topic. Thank you.